Hey everybody, this is Larry. This is day 9, day 10 of the Leetcode Daily Challenge. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about today's poem. I have a really funky hat here right now, so I don't know. A huge forehead for some reason. But yeah, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Maximum product of split binary tree. So given the root of a tree, split it into two subtrees, and then the product of the sum of the subtrees are maximized. Okay. Return the maximum part of the sum. Since the answer is too large, return a mod. And you have to maximize the answer before taking the mod, not afterwards. So that mod is kind of, I don't know. Yeah, let's see. Well, let's look at the constraints. 5 to 10 to the 4. So it's like 5 times 10 to, so then, yeah, it's going to be, I don't know. I mean, I guess my thing that I'm thinking about is just how it's going to, how do you do the mod in a good way from if you're not using if you're using a language that like more specifically like JavaScript or something like that, can you do it? I don't know. And you have 5 times 10 to the 4th nodes, so that means, let's say, if you balance it perfectly, it's half of these, right? So so you have half of those, you have 5, that means that if you summed it up, it's 5 times 10 to the 8, something like this, or 10 to the 8, say, and then you multiply it, it's going to be 10 to the 16, right? Which I think maybe overflows Java, because Java doesn't have a 64-bit int. So if you use Java, or not Java, sorry, JavaScript doesn't have a 64-bit int, right? So if you use JavaScript, you may be a little bit out of luck. You may have to use another thing. But otherwise, this is pretty, I wouldn't say it's straightforward, but I think so. There are a couple of ways you can do this problem. The way that I'm going to do it is just by recursion. The way to think about it is basically, instead of thinking about one of the subtree and then the other subtree, the way to think about it might be to think about it in terms of here. Let's just say the one of these tree. I'm using one of the examples here. I don't know if you could see me highlighting it. Let's say one of the trees, let's just say A, and then the other tree is B, and you're trying to find A times B, right? What you can do instead is say find C, which is the entire tree. So then it becomes A and C minus A. So that's probably the way that I would think about it in terms of tree, and I think that's probably it. So let's try to do that. So then let's just get a total thing. If node is none, return 0. Return node dot value plus total of node dot left plus total of node dot right, and then this will get oops. So I don't know. T is equal to total of root, right? So then now we can calculate a subsum, right? So basically, let's just get traverse node, and maybe I guess we could just use T from above. You could also pass it in if you like, but it doesn't really matter either way, right? Node is none, then we return 0. Again, this is to return the sum of the subtree, right? So then node.value plus traverse node.left plus traverse node.right. And you could probably put in one function, but that's fine. But basically, so let's say this is the value here, which is what I call A, and this is basically the value of all the nodes in the subtree, right? That means that what you're cutting off is the edge that's connected to this node going upwards. That's basically the idea. And then B is equal to T minus A. And then now we have a best variable. I mean, and you could do it in a number of ways. But since we're going to maximize, we put 0, and then best non-local best is equal to max of best A times B, right? And then we just return A because that's the node, that's the sum of the tree again. And yeah, and that's pretty much it. We return best at the very end after traversing from the root. I think in theory there is a case where b is 0, but this will return 0 anyway, so it doesn't change the answer. So we don't have to worry about it, I think. So yeah, let's give it a run. Let's give it a submit. Oh snap! Oh, I forgot to mod it. This is what happens when you don't sing the mod song. I knew that I had to mod it. I even thought about it, but then I just forgot to sing the mod song. So mod. Larry is sad mod, right? So you just only mod it at the end. And since all the intermediate values fits in the 64-bit ends, that should be good enough. Apparently, I did this a while ago. Though this is the first time I got it wrong, which is sad because I forgot to sing the mod song. Because I was too distracted by I don't know, all these nuances that I was explaining, where I don't know, you forget the matter and put in matter. But yeah, this is going to be linear time, linear space. This is linear time. Just looking at each node twice, and then linear space because that's the size of the implicit stack O of H. Cool. That's pretty much all I have for this one. Let me know what you think. Sorry if my explanation is not that good today. I think I've done this a couple of times. So yeah, someone told me that I have to do the weekly, and I actually forgot to do the weekly. And apparently there's only 4 days left, so I just forgot to look for it, to be honest, because I don't. So I'm going to do that right afterwards. But otherwise, I don't know. I think I had too spicy food earlier today, so I think my voice is a little bit losing it. So I'm just going to do it very quickly. That's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. Have a great weekend, everybody. I'll see you later and take care. Bye-bye.